Hello everyone, welcome back to our YouTube channel Becoming a Rose Developer. I'm Desire, and today we've got Jason, who has just completed the course Linux Basics for Robotics, and he'll be giving us a presentation on that. So without a waste of time, let me now hand over the platform to him so he can begin his presentation. Alright Jason, whenever you're ready.
Yeah. Hello, my name is Jason, and just gonna do a simple presentation on my final project for the course Linux Basics for Robotics. So the final project is making obstacle avoiding machine. So using the robot TurtleBot, but here we're gonna use FastBot. So first I learned how to simulate a TurtleBot using Lisbo and Arvis, and then explore the movements, and then I created a ROS2 package. Just a second, let me show you. These are commands.
I think can you show your final product, so the scripts that you've developed running, so that you don't run out of time with the robot?
Okay. So let me show you.
Yeah, or you could maybe add an extra slot if you'd want more time.
Well, I think I will finish it within.
Okay, no worries.
Taking the time. So this is the folder, and here I created a XML package named Linux Basics project. And here, as you can see, these are my functions that I have done and created. So here, this is my second part of the project, which is a simple patrol, one for simulation, and the other one is for the real robot. And I have created three bash programs. One is for robot functions. It has the functions, the common functions that we'll be using for other part of the program as well. And robot statistics is to display all the angular velocity and the IMU sensors, the data from IMU sensors. And obstacle hour bash is the commands and codes for the actual working. And robot interface is okay. So first off, so shall I show my project then? No?
Yeah, so what I meant was that,
Yes,
can you run the obstacle avoidance script, right? Because that's the one that's going to show us what you managed to accomplish. And then you can run the statistics script as well, so that we see that this stuff works and is expected.
Can I use the notebook?
I say that again?
Can I use the notebook, refer the notebook?
Yeah, you can, depending on what you're doing. But in our criteria, we would have to see if that was something that's not considered to be cheating. Are you trying to launch the visual script, or the one script that gives you the ability to launch RVs? Yeah, you could copy that and just paste it in real quick so that you don't run out of time.
It's copy paste is actually not working.
Oh, you can double tap
It's
and
not
Control
working.
A.
Sorry?
So you can double tap that cell, then Control A to highlight everything, and then you can copy. Yeah, this cell.
Really?
Then Control A.
It doesn't copy. It doesn't paste you.
Okay, interesting. Let's see. You could use Control C. I think that should work for you.
I'll just hope it works. Okay, so we first source this, and then we use ROS tool. It's a command, and you launch this the bot, fast bot. So the syntax is ROS2 launch and the package name and the firm.
So what is the purpose of this script that you've just run?
This launches the XML package, the main fastbot lab.
And what do you need that for?
Uh, to establish the connection from a device and the robot.
Say that again.
To establish a connection.
To establish the connection with what?
The robot. The robot.
You're already connected to the robot, I think.
I mean, yeah. ROS to run. It's the program that runs on it.
Yeah, so you remember when I said, can you move the robot forwards and backwards using the joystick, right? That means you're already connected to the robot. So there is something that this script is happening, and what I want to know is, why do you need to launch this, right? For your own, your project, for your presentation, why do you need it?
Okay. So we're doing this because I'm not sure why, but as far as I learned, I think so basically we're using this to launch this package. So this package enables us to use the robot, is what I remember most.
Not necessarily, right? So this is part of the criteria of looking into understanding if you do understand what your project entails, right? So the script that you're launching, it does not give you any ability to move the robot in any way, right? What it does is it allows you to visualize certain sensor data that you're getting from the robot, right? And I think if you look through it or the notebook, clearly you should be able to see that, right? So I would want to understand, or I would want to know, as someone who's looking at your work, that you understand what you're launching, right? You can do away without this completely, right? So if you cannot explain the significance of it, to me that's a little bit worrying. However, for now, let's go on and then we can speak about it a bit later.
So we have another terminal. I think this is gonna get over the timeline.
Yeah. Okay. So check if you can get another booking, so that we can at least demonstrate that the robot works, or it moves in the way that's expected.
The zone available.
There should be, okay, so there's no available slot. Alright, so there isn't much we can do for this one. We have to postpone to your next available
No, it's
slot.
not available. The next slot is available, sir.
Oh, we are currently on this one. Try booking that one and let's see.
Yeah, it's confirmed.
All right, all good. So now you can get back to the explanation and let's see it work in simulation at least, and then you can be explaining what's going on as we wait for the timeline to pass.
Okay, so I was in the simulation right now.
Yeah, because you're not connected. Well, you have got about 58 seconds. You could try to do something with those. If you can be quick. Otherwise, we still. Okay, good. So just disconnect and then let's do our demo in simulation for these 5 minutes. You could try pressing tab if your packages are already available. So the terminal autocomplete for you or give you an option of what's available.
What?
Press tab or tab twice. Tab twice, yeah.
Okay.
Then it will help you.
So like you said, it's to detachment sensing. I only open other terminal. So this is simulation.
Sorry, you said?
So I'm showing the simulation right now.
Yep, alright, so let's see it from the top. Alright, that's good enough, yep.
Is this fine?
Yeah, it's fine.
Okay, first, we gotta go to the directory where my plans are stored, files. These are my bash commands and Python commands, Python codes. First, run the robot interface. It's ready, so we open another terminal. We open different terminals because it cannot run same file again.
Okay.
Lagging. Am I connected?
Yep, I can hear you. So your internet should be fine.
Now, I launched the obstacle over there.
You do know that you could have run that in the first terminal, right? By just switching to the second tab.
Yeah, I know.
Okay.
Now I'll run the statistics. Here you can see the robot is moving.
Mm-hmm. Yeah.
So a certain threshold. Shall I show my code? I'm in the dashboard.
No, not at the moment. So let's see this working first, and then we'd want to switch to the real robot because the time is on now.
I think it's we can use the real robot now.
No worries. Let's give this its time to run. So you can enlarge the gazebo window and let's view it from the top. And then use the orange box there to choose perspective on top. No, on top of the gazebo window, right? And then, yeah, use that orange box so that we see the robot from the top.
Lagging.
Yeah, let's give it a bit of time. Try refreshing. So you go on the extreme right. There's extreme right. Extreme right in the graphical tools window, right? There's that arrow that allows you to pop out of this page to open the next page. There's also this circular arrow. Yeah, that one. Yep. Yeah, it looks like your robot collided with the wall there, according to what RFS is showing us. Okay. Let's stop this and try to do a demo on the real robot. So just terminate all the running scripts and then connect to the robot. Or you could just go on the robot listings and then you can connect.
The camera's taking time to load. Shall I start?
Yeah, no worries. We can see this other window, so it's okay. Is the robot responding to you, to the...
No, it's not.
Okay, can you run rows to topic list? We just want to see if all the topics are available. You have to yeah, there has to be space between topic and list. Okay, so you should be connected. So try running tailop. So use tailop to convert. Do you know the command? It's right next to... yeah, copy that one.
Doesn't copy.
But can you highlight the cell? So can you tap inside the cell?
Yeah.
Yeah, so press Ctrl A in that cell and then Ctrl V in the terminal. Try Ctrl V, otherwise you might struggle with that other option. Is it working?
No.
Okay, so maybe the shortcut is not available to you. It's still not moving.
Sorry?
Okay, now it's moving. Okay. Okay, so then run your scripts and let's see, since it's responding to tailop, it means you can use it. Can you enlarge the window so we can see close to where the robot is? Okay, I see it's rotating now. Okay. Okay, so can you open the IDE? I would want to see your statistics scripts, right? So I want to understand what's going on there. You can find the IDE at the bottom next to the terminal icon.
Right?
Yes, can you open the code editor? Yeah. So, and then navigate to your statistics script. Alright, can you enlarge that? Alright, can you tell me a bit about what this script is doing?
Yeah. First we initialize the room position here. Am I audible?
Yes, I can hear you. It's just that, can you speak more clearly at least?
More clear. Okay now.
Yeah, it's fine. Yeah, it's some words
Yeah,
were
so
not very clear.
okay. Is it still facing the same problem?
Alright, so go ahead.
Okay. So first we store initial room positions. We store the x value and the y value, and then we set the distance to 0 first. Calculate this distance, and then we get the current position. Here's the initial position. Here's the current position. We store x, y position, and then we calculate the distance from the start. We calculate x distance and y distance.
Alright, so I see you're using ROS2 topic echo or DOM, and you echo it once, then you grab the values x, y, and z. Are you getting any useful information via that? Do you have odometry coming, or
We get the position. We get the points, the position of the.
okay? Can you run one of those commands in the terminal, right, directly?
This one?
Yeah, so just get the function that you're using to extract x and y values. I want one of them, right? So you could pick the one that's extracting the x value. You should be able to run the first part that says ROS2 topic echo odom once, right? That's the one we want to see. I don't think that's what I would want you to do in this regard, unless you're trying to get something else. What I just want you to do is to echo that topic, right? So just run ROS2 topic echo odom once. Is this your own implementation, or?
Sorry?
Okay, there you've got odometry values. Okay, that's good. Okay, no worries. Okay, so go on. So I want a proper explanation of the things you're trying to get in this script, right? So you have to tell me why you're getting that information and how you're getting it, right? So try to be as thorough as possible so that we understand what exactly you did and which features are you trying to extract using this script.
Okay. Here we use rows topic echo DOM to get the value of x, y, and here we use grep for pattern matching so that we get the x value.
What x value, right? You have to explain in the context of what you're doing with the robot, right? What does the x value stand for?
X value stands for the coordinates of the robot.
The coordinates of the robot, right? Relative to it has to be relative to something, right?
The simulation that we show. So here, as you can see, this is the grid, right?
All right. I see. Okay, let's go on.
Yeah, and then we calculate the distance from the start. Here we initialize it to 0, and then we print the current direction based on yaw, if it's going front to back, that is. And then print the roll, and then the bit. I mean, we don't need base right now, we just roll. And then again we print the angular velocity, so how fast it's going. And then we print the acceleration on how fast it accelerates on each axis, x, y, z. It's obviously going to be 0. And then we update the current position.
Okay, all right. So
it again goes back to the start.
All right. So let's see the obstacle avoider base script, and then you can go through it as well. You've got about 5 more minutes.
Okay. So obstacle, actually divided this into 8 conditions. Okay. So first, we make sure that robot is stopped initially. And then I set the obstacle to threshold to 0.3 meters.
What does that do? What is the purpose of threshold, right? What does it mean in the context of what you're doing?
So what it means that the robot would have to maintain at 0.3 meters from the obstacle.
Okay, all right.
Okay. So first it's a while loop, and here we get the I've told already before the robot functions that we set a few functions. So here is the getter functions now. So first this is left range, and this is front left. So I've analyzed 5 different directions. First is front, and then a front left, front right, and then right and left.
Okay.
So first we print the ranges and see if the front left, front and front right distances are greater than a threshold. If it's not, it will return -1.
If it's not, what happens? Say that again.
It returns 0.
Okay, all right. So that's what you're using as your condition true or condition false. Okay.
Yeah. Okay. So then in this if condition, we check. So this is the case 1. If front left is not free and front right is not free. So what happens is it either turns left or it turns right based on the which range has more value. So suppose if there's more space in the left, it turns left. If there's less space in the if there's more space in the right, it goes right.
Okay.
So we set for positive, if you want to turn left, it's 0.75. And
how did you get to that value? Did you just pick randomly? Did you use some cost heuristic? How did you get to 0.75?
It's just like a trial and error.
Okay, all right.
And then we make it sleep because to make it more smooth, we make it sleep for 1 second.
Okay.
And then I stop it. We set the angular velocity to 0 again.
Okay, can you tell me something? What happens if you don't let it sleep, right? Did you try that case?
Yeah, so actually what happens is, so if you don't let it, actually the sleep is because as it moves, you don't have to like stop it immediately. Mm.
Maybe I think try explaining that in a different way. I don't think I got that correctly. So if you don't call sleep, what happens?
I think in this case, I don't think it happens. Like I just check for few other
Okay, so
functions.
the as you write your code, right, you have statements that you put in your code for a particular reason, right? So if you fail to explain this, and it is very crucial, that is not a good sign, right? Why do you have to make it sleep, right? Why did you need to write it there, right? I could have put sleep somewhere after 0 or somewhere after set command fail to 0 and then put sleep there, right? So why there? Why in that position? Why in line 46?
Made it. I've added every sleep for after every movement because it'll make the robot go more smoothly. Suppose if I don't have well, in this case, even if I remove sleep here, it'll stop automatically.
It will stop automatically. Okay.
Because I've set the angular.
Does it?
So let me just explain it.
Okay.
Yeah. So
okay.
what happens is.
Yeah. Go ahead. Go ahead.
Yeah. So what happens is, so I set the angular velocity as 0.75. So I'll let it run for 1 second.
If you set angular velocity to 0.75 and then you let it sleep for 1 second and then
I make it stop by adding by setting it to 0.00.
Okay, so you see, the reason why I'm asking this question is I want you to explain to me what is the effect of calling that, of calling sleep with regards to how your robot moves, right? So you said it's going to move more smoothly, right? But if you remove it, does it move the same distance? What happens, right? That's why I was asking, did you try running it without calling sleep? Because clearly it's doing something, but your explanation is not satisfactory to me. You're not explaining it clearly why it's required there. We know that the robot is going to stop at some point, but that's a default mechanism that's put in the system, right? Maybe to protect you from having it crash into the wall. But for the purposes of what you're doing, there is a more specific reason of having that there. That's what I want to get.
So if you just set here as 0.75, it will just keep rotating. So we make it sleep after 1 second. We make it run. I make it turn for 1 second, and then I set it to 0.00.
Yeah, okay, that's more like it, right? Because you are saying I'm setting this to a particular value and you have to execute for this length of time, right? I think that is more plausible to me. Smoothness, not really. That's not what is happening here. So that's why it's very important for you to try and understand as much information about whatever code base you're trying to use or what sample code you're using, right? I understand you're given some of this information from the course notes, right? But if you don't make a due diligence for yourself to understand what is going on here, it can work, right? But it doesn't help you much because you don't understand what is going on there. What is the effect of that stuff on the behavior of the robot. This is what we're looking for. This is what I look for when I examine, right? So when I ask these questions, I expect you to give me as much information as possible, because it's what means, or it's what's going to show that you understand the work that you did, right? Yeah, so I think on that note, let's end it here, and then we can finish your conversation on Zoom, alright?
Okay.
Alright. Alright everyone, this was Jason's presentation, and I would like to encourage all those of you who would want to try this course or any other that we offer certification on to do so, and then you can also come and make a presentation, showcase your work, and do your best to explain as much as possible what you've understood and the code that you've developed. So until next time, keep pushing.